Welcome to our last section, section 2.8, vertical angles. The objective of this section is to recognize opposite rays and vertical angles. Tomorrow in class we'll be working on page 102, numbers 1 through 12 and 15. First thing we need to do is define opposite rays. Opposite rays are two rays that have a common endpoint and extend in two different directions. In other words, two rays that when combined form a straight line. So let's look at this picture and let's name the opposite rays. The opposite rays in this picture is going to be ray OT and ray OP. Ray OT starts at O and goes towards T forever. Ray OP, again, starts at O and goes towards P forever. Combined, they give us a straight line. Next, we need to define vertical angles. Vertical angles are two angles formed by a pair of opposite rays. Vertical angles, what I like to think of, is kind of like little fishy kissing. So if we look at this picture that we have right in here, and I extend these to form little fish, where the fishies are going to be kissing, that's where we got our vertical angles. In this case, one pair of vertical angles would be angle AED and angle BEC. Where would be the other pair of vertical angles? You should have angle AEB and angle DEC. Now, besides little fishy kissing, the other ways people think about these vertical angles is we call them our bow tie angles. So if you think about a bow tie, or an hourglass even, where they meet, that's where those vertical angles are going to be formed. Next, we're going to talk about the vertical angle theorem. The vertical angle theorem states vertical angles are congruent. The way we're going to kind of shorten this up is what we're going to say is VA congruent. So let's look at this. We got a pair of intersecting lines. We'll call this A, B, C, D, and the intersection will be E. What we can then say is angle AED is going to be congruent to angle BEC, or angle AEB is going to be congruent to angle DEC. Alright, so let's try some examples based on vertical angles, the vertical angle theorem, and opposite rays. Alright, so here's our first problem. We want to find the value of x and the measure of angle 1. So here we go. Looking at this picture, I see that I have vertical angles formed. I see my bow ties, or whatever you want to call that. Let me erase over that so we see what that is. There we go. Now, we know vertical angles are congruent, so I'm going to take 3x plus 16 instead of equal to 5x minus 8, and I'm going to solve for x. Subtract my 3x to both sides, add my 8, and that leaves me with 24 equals 2x, so x is equal to 12. That's the first part. The second part, I want to find the measure of angle 1. So I'm going to take that 12 and I'm going to plug it back in here. 12 times 5 is 60, and 60 minus 8 gives me a 52-degree angle. Now, I see that these two angles are supplementary. So to find the measure of angle 1, I'm going to take 180 and I'm going to subtract 52. And the measure of angle 1 is going to be 128 degrees. What do you think? Not so bad? I didn't think so. Alright, so let's move more into doing our proofs. So here we go. We got our statements and our reasons. So it starts off with our givens. Angle 1 is congruent to angle 2. Given. Angle 3 is congruent to angle 4. That's given. Now let's look at our picture. You see those little fishy kissing or those bow ties? We got angle 2 is congruent to angle 3. Why? Because vertical angles are congruent. Now, do we see any repeats here? Well, I know I sure do. Angle angle 2 repeats and angle 3 repeats. And what I'm left with is angle 1 is congruent to angle 4. And what property says we can do that? It's the transitive property. Perfect. So a nice 4-step problem. Alright, here's our last example. Again, we got another proof forming right over here. So let's start off with our statements and our reasons. It starts off with angle 2 is supplementary to angle 4. That's given. Alright, so what do you think? Where should we go from here? We want to eventually start talking about angle 1 being congruent to angle 3. Why don't you press pause and let's see what we can do. Alright, so here we go. Next thing that I see is I see that angle 3 is congruent to angle 4. The reason? Because vertical angles are congruent. Now, got a couple options here, so we've got to think about which option we kind of want to use. Alright, here's what I'm going to do. I'm going to use the substitution property. Every time I see angle 4, I can replace angle 4 with an angle 3. So let's do that. Angle 2 is supplementary to angle 3. For my reason why, it's substitution. Well, that didn't quite get me to where I want to be. So let's keep going. Here's the next thing that I have. I see that I have a straight angle formed. Anytime I have straight angles formed, especially with no letters with them, I can jump right into forming supplementary angles. I can say that angle 1 is supplementary to angle 2. The reason is if two angles form a straight angle, they are supplementary. Now, next, I'm looking for repeats within my supplementary steps, and I see that angle 2 has been repeated. What I'm left with is angle 1 is congruent to angle 3, and our reason. Supplements of the same angle are congruent. Not so bad, right? Beautiful. Last but certainly not least, our classwork answers. So, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 15. Look through these problems and give it a good look. If you know you're going to have problems with some of these questions, make sure you ask them before we get started tomorrow. Have a good one.